Hello friends, in the last lecture we were talking about virtual machine and I think we came up to this part, VMware architecture. We have talked about system models in our last lecture. Today we are going to talk about VMware architecture. So this is the actual architecture. This is your actual computer hardware. See, when we are talking about virtual machine, you are using a single system or single computer, and you are using different operating systems on the same computer. That means you are using virtual machines. Okay, but as you are using a single computer, your hardware resources will be limited. Okay, and these resources will be shared among your systems, virtual operating systems. Okay, so this is the hardware part, and this is host operating system. And see, this is your virtualization layer. And in your virtualization layer, you can use different operating systems. And these are your applications running on your host operating system. So if you are using virtual machine, VMware workstation, something like VMware workstation, let's say with your host operating system Linux. Okay, and in that you are going to virtually install Windows or vice versa. And while you are using VMware workstation, see, it's kind of an application, and this is you can also run another applications, different other applications while you are running that VMware workstation. Okay, so I hope you have understood the architecture. Next is, let's see the definitions of your host operating system and your guest operating system. The operating system actually running on the hardware is called as your host operating system. Together with virtualization layers, it simulates environment for your guest operating system. Okay, and next point is guest operating system, and its definition is the operating system running in the simulated environment. So I think this will be helpful. Let me open my VMware workstation. See, this is, you can call it as an application. And see, I have already I already have the setup for this operating system. Okay, see, these resources are allotted to this operating system. Okay, 20 GB of hard drive space is allotted for this operating system, and from here I can power on this virtual machine. See, here I have other different systems. Okay, and I can just click on any of that, and I can work on those operating systems. So see, I'm using a single computer, but I can use different operating systems. That is the basis for your virtual machines. Okay, so when see, I'm going to use this operating system, different operating system, but I'm going to consider this as another machine. So it will work as another different computer. Okay, but it is using same hardware resources. So my host operating system for my this computer will be Windows 10, and guest operating system, we can say that this is actually CentOS operating system. So CentOS operating system is my guest operating system in this case. Okay. Now let's talk about types of virtual machine. First type is system virtual machine. These provide a complete substitute for the targeted real machine and a level of functionality required for the execution of a complete operating system. So, system virtual machine means you can have a virtual machine which works kind of like another computer. Okay, that's why it is called a system virtual machine. Okay, see here you can see the structure. See, this is your hardware. Next is virtual machine monitor, VMM, and see these are two different operating systems: simulated machine, and their operating systems. Okay, and their apps running on this machine. These are the apps running on this machine. So this is called a system virtual machine. Okay, the example I just shown you, that is you can also call that as system virtual machine, as those operating systems, those machines, they can work as different machines, different simulated machines. Okay. Next type is process virtual machine. Process virtual machines are designed to execute a single computer program by providing an abstracted and platform independent program execution environment. A process virtual machine, sometimes called an application virtual machine or managed runtime environment. Process virtual machine is created when the process is started and destroyed when it exits. A process virtual machine provides a high level abstraction, that of a high level programming language, compared to the low level ISA abstraction of the system. Process virtual machines are implemented using an interpreter. Performance comparable to compiled programming languages is achieved by the use of just-in-time compilation. And see, this is the structure of your process virtual machine. This is your hardware, this is your operating system, and this is your virtual machine. Okay, so that's why this is called as process virtual machine. Next one is language virtual machine. This type of virtual machine has become popular with the Java programming language, which is implemented using Java virtual machine. The Parrot virtual machine and the .NET framework, which runs on a VM called the Common Language Runtime. All of them can serve as an abstraction layer from for any computer language. Unlike other process virtual machines, these systems do not provide a specific programming language but are embedded in an existing language. Typically, such a system provides bindings for several languages, for example, C and Fortran. Uh, Examples are parallel virtual machine and message passing interface. They are not strictly virtual machines, as the applications running on top still have access to all operating system services and are therefore not confined to the system model. This is the structure for Java virtual machine. Our next point is hypervisor. A hypervisor or virtual machine monitor is a piece of computer software, firmware, or hardware that creates and runs virtual machines. A computer on which a hypervisor is running one or more virtual machines is defined as a host machine. Each virtual machine is called a guest machine. Hypervisor is a bare metal approach is installed on the bare metal and then the operating system is installed. So we can call it as para virtualized. So there are different types of hypervisor. First one is bare metal. Second one is hosted. This is the structure of bare metal hypervisor. And this is the structure of hosted hypervisor. Okay, now let's see how can we implement virtual machine monitors. These or hypervisors, they vary greatly with options including type 0 hypervisors, hardware-based solutions that provide support for virtual machine creation and management via firmware. Type 1 hypervisors, operating system like software built to provide virtualization. Examples are VMware ESX, Joint SmartOS. Uh, Type 1 hypervisors also include general purpose operating system that provide standard functions as well as VMM functions. So it will include Microsoft Windows Server with Hyper-V hypervisor and Red Hat Linux with KVM. Next type is type 2 hypervisors, applications that run on standard operating systems but provide VMM features to guest operating systems, including VMware Workstation and Fusion, Parallel Desktop, and Oracle VirtualBox. Other variations include para-virtualization, technique in which the guest operating system is modified to work in cooperation with the virtual machine monitor to optimize performance. Next is programming environment virtualization. VMMs do not virtualize real hardware, but instead create an optimized virtual system. It is used by Oracle Java and Microsoft .NET. Emulators allow emulators allow applications written for one hardware environment to run on very different hardware environment, such as different types of CPU. Next is application containment. Uh, this is not actually virtualization, but rather provides virtualization-like features by segregating applications from the operating system, making them more secure, manageable. Much variation due to breadth, depth, and importance of virtualization in modern computing. So, you must be wondering what is actually virtualization. So, virtualization is defined as the abstraction of objects, creating a virtual rather than actual version of objects, such as a server or storage device. For example, when you partition a hard drive into two partitions, you create virtual drives, but the physical hard drive has not changed. Or you can say virtualization is a technology to run multiple same or different operating systems, which is completely isolated from each other. Run both Windows and Linux on the same machine. So this process of running another virtual machine on the same computer is called as virtualization. So my one computer will act as more than one computers, and this is called as virtualization. But there is no actual another computer. I'm just using it virtual. That's why it is called as virtualization. So there are different types of virtualization. First is server virtualization, desktop virtualization, application virtualization, memory virtualization, storage virtualization, data virtualization, and network virtualization. Server virtualization is hardware virtualization or platform virtualization refers to the creation of a virtual machine that acts like a real computer with an operating system. Software executed on these virtual machines is separated from the underlying hardware resources. Different types of hardware virtualization include full virtualization, partial virtualization, and para virtualization. Full virtualization means complete simulation of the actual hardware to allow software, which typically consists of a guest operating system, to run unmodified. Partial virtualization means some but not all of the target environment is simulated. Some guest programs therefore may need modifications to run in this virtual environment. Next one is para virtualization. This is a hardware environment is not simulated. However, the guest programs are executed in their own isolated domains as if they are running on a separate system. Guest programs need to be specifically modified to run in this environment. Uh, these are basic normal server issues: backup, rebuild operating system, data recovery, disaster recovery, same vendor, and last one is same model. And their solution is consolidation, shared CPU, memory, NIC disk, maximum utilization should be 90 to 95%, centralized management, migration, and less space. As we are using different machines on the same computer, we are sharing the hardware resources. That's why the utilization of your hardware resources is 90 to 95%. And the manage as you have to manage different computers or different virtual machines, there should be a there is a centralized management part. And by migration, I mean you can actually copy one operating system and you can run that operating system on another hardware. So it is very easy. The migration is very easy in this case. And as we are sharing the resources, it requires less amount of space. Okay, so we'll stop here. We'll discuss this benefit of server virtualization in our next lecture.